Okay, welcome back generals to another Let's Fix Generals Zero to make the best game ever. Good, so we have put together a lot of changes. Oof. Yes, and now we need to see two cons pointer, two pointer array. Okay, do we use this stuff here? We don't. Do we use this one? Okay, this we use. This as well, but we don't use this, so let's delete that. Okay. Good, then we have this guy. And okay, we added the span. Yeah, add span. There's a to do. Can we use without getting the test? Okay, const function pair. Okay, that's fair. Const function pair. Yeah, okay, all this is fair. ASM matcher types. Okay, here we have a whole bunch of changes. Let's go with the simple stuff first. Not this. We removed the nearest symbol stuff. Maybe we should have this as a separate change. Hold on. Function. Yeah, it's just these guys, right? Anything else? Remove get nearest symbol functions. Remove function. Remove obsoletes. Remove obsoletes. Get nearest symbol. Yeah. Commit. Okay, let's stash. Compile. That works. Okay, then we do stash pop. Okay, then next we fixed here the symbol thingy. This, that. this, revert this. Save symbols in save PDB symbols in PDB config. PDB symbols. Okay, commits. All right. Stash. Oof, we got an error. Ah, I know why. Here, we are missing this as well. Stage. Stage. Stash. Okay, excellent. Stash pop. Okay, next, PDB reader. PDB reader. Let's take this stuff, this, and so this was in unassemblize before. Common types. Are we using this? Okay, looks like we are not using this, so let's remove that. Okay, so I think we just add this. Add function symbol look. Add function symbol lookup by Add function symbol lookup by address to PDB reader. Add function symbol lookup by address to PDB reader. Commits. Stash. Compile. Okay. Stash pop. And next. Well, downcast is not a type. That is actually a util. Maybe we should move it to util function. Yeah. Downcast. Then we take assert.h and put it to util. Actually, let's leave it here for now. Downcast. Let's leave this in unassemblize namespace. And the span as well. Bundle file index is smaller too, and PDB is not null pointer. It's not, yeah. probably correct. Let's compile this. Okay, so 2-point array. Yeah. Const point array. 2-point const. Yeah. Span. Yeah. Const string. Do we use this here? We don't. Then we can remove it. We probably want to move these guys up here. This we are using, right? Yeah. Function pair. Function pair. Why is this called executable pair 2? Ah, because there is another one. I see. Unique point. Can we also use util, or what is it? Where is it? This one. No. Let me see. Is there actually a justification for these helper functions here? Let me see. Okay, we use it just once. Yeah, we use each once here. Maybe this is not necessary, and we just say this 0 1. Yeah, I think that is simply enough. Same here. Let's do that. I think that's better. Good, then we can remove this again. Do we have other pair functions? Pair. Yes. Okay. All right. Okay, so I think this here is fine. Oof. Oof. I hope that this logic is all correct. I'm not 100% sure. Well, we will see it later, I guess. Has completed this. Well, we can look at it once more and see if things look. Disassembled count. This plus this. Compared. It's completed. Updates. Matched, unmatched. Name functions. This disassembled. Is disassembled? Yeah, okay. Mm-hmm. Matched. Here we have some. Why don't we put also here this? Might as well do it here. Doesn't have to be 100% compact. Leave a little bit of breathing room here for the eyes. Yeah. Okay, that's fair. Matched, unmatched. Matched is compared. Is compared. Is compared. Match functions is compared. Yeah. Yeah. So basically, these checks are there so that later on we can check in the UI, is this actually already compared? If yes, then no need to process it again, right? Job is done. And since there are different ways to work on these individual functions and matches, we need a way of checking, because you can select different things that you want to process, and some of these things might already be processed and complete, and others may not. So you need to check, okay, is this done or not? Yes, it's done. Okay, skip it until everything is successfully completed. Yeah. Yeah, this should work. We added a lot of logic here, I have to say. Good. Yeah, count of function. Oh, we got a typo here. Disassembled count. Count of functions that have been disassembled in this bundle. Count of functions that have been linked to source files in this bundle. Count of functions that cannot be linked to source files. Well, in this bundle, I mean, it's kind of implicit, isn't it? Count of functions that have been disassembled. Let's remove this last part here. Count of matched functions that have been compared with each other. Count of matched functions that have been compared. That have been compared. Count of matched functions that have been compared. Yeah, I guess we. So, yeah. Maybe we also have some more functions. Two const function pair. This one we should keep, I think, because it's complicated enough here. This is a bit hard to read, this one here, because it's in one line. It's a typical Clang format of on, and now it's readable. Clang format is retarded, absolutely retarded. I'm not a fan of auto formatting. I think that formatting should always be done by hand, because programmer will 100% make a better job than automatic formatting, because every problem, like every lines of code need different treatment. Like sometimes you need some spacing here and there, sometimes you need some line break, and like if you automate it, you can't get this right. Like this is harder to look at than this. 100%, 100, 200, 1,000,000%. This is harder to look at than this. But the machine doesn't know this. The Clang formatter doesn't know this because it's stupid. It just has a fixed rule, and yeah, it doesn't understand the context that this is much easier to comprehend. Of course, it doesn't understand. That's why I think it's retarded, because you need to write the code in a way that you can read it, and not that a machine has a nice way of easily formatting it. That's stupid. So I'm not a fan of auto formats. I don't know why people do it. Probably so that, like, because most people cannot make a consistent format by hand. Maybe that's why. But if you focus and you incorporate formatting as part of your duty to write good code, you can absolutely do it. You don't need a formatter. Absolutely not. Anyway. Yeah, then I think this looks pretty solid. Then I think we can stage this one, yeah. Named functions. Do we use all of these? Oof, so many types here. Name functions, yeah. This one we use as well. This as well. And this as well, yeah. Good, then we take all this. Here we have a bunch of new functions, and that is fine. Is disassembled. Blah, 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 blah. Okay. Good. Good, here we have, yeah. Okay. Const function pair. Yeah, this looks good. And now the core of the change. Okay, so bundling PDP read. Yeah. Okay. Bundle file. Okay. Oof. Oof. Huge change. Yeah, I think we spent not enough time with it. Should be good. Yeah. Reserve. We got a lot of good reserving here, right? And resizing. I think so. Yeah. There's no magic numbers, no guessing. Well, there is some estimating, but there's no guessing. Yeah. Mm. There's a lot of changes. We removed this assert because it was hit. Okay. Output comparison. Okay. Yeah, a lot of new functions. Yeah, I think we just take this all. So this assert was not hit. Yeah. Okay, that's good. So much. Name function. Yeah, let's try to review it anyway, just to make sure. Name function size. Name functions I. Build name functions. Get executable I. Yeah. Fair. Name matched functions. Build matched functions. Yeah. Simple enough. Build match bundles. Named we pass this all. Yeah, that's also fine. Disassemble matched functions. That's fair. Build source lines for matched functions. Also fair. Build comparison records. Also fair. Here we just added this. Const name function pair. Const name function pair. That's new. Const name function pair. Const name. Because this yeah, okay, that's fair. Build function name to index map. Build function address to index map. Size t, reserve, map. I wonder. It doesn't matter. I wonder if map insert would be faster than map access operator. I'm not sure. Because it's probably similar. Because in the insert, with the insert, it's also let's do this first. But I'm curious. C++ fastest way to insert to map. So we have insert, make pair, or this. Let's see. Inserts. Functionally equivalent to inserts. Oh, well, that's a little bit too complicated. Requires the map type to be assignable, which isn't always the case. Can overwrite existing elements and gives you no way to tell whether this has happened. The other forms of insert that you preset. Emplace method. This is nice. Works fine with move only. Slightly more efficient. We'll search for the key. Inefficient. Yeah. So I think the operator, this is not efficient. In place. Plus we can't check if we insert duplicates this way. Insert us. Try and place. Try and place. Does modify its argument if insertion fails. Try and place. Try and place. Try and place. Oh, there's a measurement. That's nice. Inserts. Okay, that's a tiny bit slower, not much. Inserts. Well, I could have shown it with emplace. What? Booster sign? What the hell is that? Yeah, maybe we make a follow-up pass on this. Okay, let's keep on going. So here we have build named functions, blah, 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 index, size, and place back named. Place back named. Shrink to fit. Okay, that's fair. Build matched functions. Auto. use the auto IT here. Maybe we can also use it at other places then. Let's see. Where's runner here? Dot find. Okay. Yeah, maybe we also use auto here. Auto. Or maybe not. So this is const string const iterator. Right. Okay. Okay. Build unmatched functions. Build unmatched functions. We pass matched functions. Name function. Yeah. In theory, the unmatched functions could also be built with just passing named functions. But this would require that this one is called before this. So then might as well just pass match functions. Yeah. I think it's fine that we pass this because we need to call this anyway to do this. So might as well pass it then. Yeah. I think that's absolutely fair. What we should do also, we should document that build match funded. Build match funded. Build match funded. This. Is matched. So build match panda. Node requires requires a prior call to build matched functions. Same here. Because bit match functions. Yeah. So build unmatched. Let's run unmatched. Name size. Unmatched. Well, not on that note. I wonder. I mean, if it requires this call, can we do anything with passing the matched? Not really, huh? No. No, it's no. This is all we need to pass. No, that's correct. Good. Named size, matched size, unmatched size. Named size is bigger equal matched size. Yeah. Matched index. Okay, whatever. Build match bundles. Blah 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 blah. Okay. Blah blah blah. Yeah, fair. Build match bundles from compilers. Build match bundles. Maybe we should rename this match bundles for compilers. Build match bundles. Build match bundles for compilers from compilers. Let's call it for, because we have some other, maybe also call it for here, for bundled functions. So let's call it build match bundles. No, from, I think it's fine. Yeah, it's fine. Okay. Build single match bundle. Match bundle, matched counts, matched. Matched functions, matched. Okay. Build match bundles, blah, blah, blah. Could also build this thing inside this function. Right? Doesn't have to live here. Yeah. So we could move this guy here. Then we remove this and this and this and this. And that way we can here remove this. Yeah. Another simplification. Much appreciated. Let's see that we didn't forget to remove it. Yeah, looks good. Good. I appreciate that. Then we save this and build match bundles. Okay. Okay. Match bundles. All right. Named setup. Named function disassemble setup. Yeah. Fair. Disassemble matched functions. Yeah. Bundled functions. Da, 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 da. Okay. Bundled functions. Da, da, da. Okay. 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 Okay, good. Excellent. Requires a prior call to build match functions. Da, da, da. Okay, good. Okay. Break down runner commands for ASM matching. No, break down runner functions for break down runner functions into smaller chunks for to smaller and more versatile chunks of work. Break down runner functions into smaller and more versatile chunks of work. Yeah, I think that is a good description. Okay, let's commit this. Oh, I'm so happy that this is done. This was really hard to do. Okay, let's look into the emplace thingy for maps. So we have this map here. So we can do try and place. Yeah, what is better, in place or try and place? me see. C++, try and place. Logarithmic in the size of the container. Okay, but that's for STD map, yeah. Inside an element and a bool. Search the place. Iterator to position. Let's do containers library. Unordered map. Unordered map. Try and place. Amortize constant on average. Worst case linear in the side of the container. Yeah, but that's very unlikely. Unless you make a hasher function that always has the same hash, I guess. Try and place. So return a pair consisting iterator and the bool value set a true if and only if the insertion took place. An iterator to the inserted element. Set to true. Auto ITB. Okay, so I think what we need to do is this comma I and then we do auto structured binding iterator and bool for B for success. Okay. IT okay. Then we do a maybe unused. And then we do assert. Okay. Okay. Let's see if that compiles. No. Why not? Conversion from size T to... Oh. Okay. So you have to explicitly cast it. Okay, index T, I, there we go. Okay. We do this address, try and place address, assert, okay. Okay. Good. Let's save this in an editor because we probably need to do it at some other places as well. So there is PDB reader. PDB reader has one, has two, multiples. Okay. Let's see. So we got this thing here. Let's take it. So we have this and this. Then we also have this here. IT address and index. Okay, and we got another here. File name Okay. It could be that we hit this assert in some places. It is possible. In that case, we can take a look at what is going on. Yeah. It's possible that we have some hits. Let's see. Okay, but we might have some more maps. Here we have another, three others. Oof. Okay, this one is never set. Okay, how does this work? I'm a bit baffled right now. It looks like it does nothing. What? Do we ever use it? Only by address. Okay, so we don't use it, and that's why we didn't realize that this is broken. That's fair. Find section by name. Find section by name. Well, I mean, if we don't use it, might as well just remove it then. Right? Sure. Question is, can we get rid of this here as well? I mean, this is broken anyway. um, um, how about we call this whole thing is stupid. Okay, let's do this. Here section info equals find section. Okay, and then we find by find by this name, and then we say if find section equals null pointer, then continue. And here we do section info, section. Well, how about we just do section type. Oh, find section. Private. Find section. Then we do for exe section info sections if section dot name equals name, then return section, otherwise return null pointer, and same here, const done, and then we don't need this map. And we don't need this. And this, and this, and this. Okay. Okay, I don't know why it does this, but let's go with it for now. It's fine. Good. Next, this one, symbol address to index map. Okay, this one is set here. Okay, so here we say IT OK1, IT1. Have this symbol address. Symbol address. Index T. Index. Okay, and we have this symbol name IT2 OK2 assert OK1 OK2. Okay. Okay, do we have more maps? Unordered map. Unordered map. Oh, I realize that this is duplicate, isn't it? Can probably remove this because we have it here. Yeah. Unordered map. Do we actually still use std map for anything, or do we just have exclusively unordered maps? We still have a map here. Huh. Why do we use... Okay, well, this one is here. Okay. Add. Das Wetter ist Vector. Okay, so here we have another case. IT, okay. This address index T. Okay. Good. Do we have more? Let's search for index map. Function also has some index map. Yeah, here this one we already looked at. PDB reader, we checked runner. No, that looks like it's it. That's it. Okay, let's see if it compiles. And it doesn't. That's not good. Okay, executable. So we need to include common types by the look of it. Include common types.h. There we go. Maybe this is not needed. IT. Okay, what's the problem here? Oh, where's this? I don't understand what the problem here is. And place, try and place, returns a pair of an iterator and a bool. Ah, it's because there is an IT already. I see. Maybe that's why. IT2, IT1. Or we just put like this. That works, I guess. Yeah, maybe we could do it. Search for the, yeah, just make an underscore. Okay, let's see. My suspicion is that we get something asserted in PDB reader. That's my suspicion. Aha. No, an executable even. Oh, okay. Let's see what it is. Initialize critical section. So that already exists. It's yeah. Why is there text data or data? Huh? How are these functions? I'm confused. Let me see. Ah, look at this. That's why that map was not used, because we set it to the wrong thing. Interesting. Interesting. Okay, let's remove this here. Okay. So, initialize critical section. Okay. And then we have another initialize critical section. Well, that is frequency imports. Okay. Value 0, size 0. But they are all at 0. All these things at 0. Well, what is the use of this? Seems to be totally useless. Address 0. Okay, let's, how about we say if address equals 0, if symbol dot address equals 0, then return. Is that fair? Let's see. So basically all the symbols that we get from the executable are will return here. Yeah. Well, it is what it is. Okay, let's see if we get any. Okay, but now we get loads. Okay, now it loads from input. No, it's still exe imports. Aha. So that, so there are some, so there are some symbols that are somehow at an address that is at 0 somehow. Okay, but there are also some valid ones. Okay, that's good. That's good. Okay, then this should, yeah, this goes through now. Okay, then let's see what the next hits. Okay, okay, we got another hit symbol, exception. Okay, what does it collide with? Ah, PDB. Overrides, true. Overrides. Symbols, pushback. Exception. Huh. Okay, so it looks like we now have a symbol that has two different addresses but the same name. Oof. Okay. Yeah. I don't know how to deal with this. Yeah, I don't know. I don't know. Here, exception. It's index 18. 18. Exception address 28748. 28748. Aha, here. Oh, no, that's different. 2748 and 2740. 27086. Okay, that's wild. That's extremely wild. Okay, I think what we need to do is then, if you know, I have no idea. I have no idea. If overwrite, then we do emplace, else that symbol name can collide. Yeah. Okay. Okay, let's see what hits next. Okay, nothing else hits. Okay, interesting. Oof. All right. So find section by name. This one, find section by name. It's just used here. Yeah. Okay. Then we don't need a lookup map. It's fine. Just search. I mean, we only have 3 sections anyway. Just search through the sections fast. That's fine. Okay. Okay. What's the time? 1 hour 40. Yeah. Okay, I would say that's good enough for the session. Then we review this tomorrow, next session, submit it, then we push it to the branch, then we merge one of the changes from Baptista, small one, and then we will add the commands. And then once we have the commands, we can continue with the UI. Yeah. Good. I think that was a good session. Yeah. Then, yeah. Still plenty of work left to do. But, yeah, we have been very busy for the last couple of weeks. When has this effort started? Beginning of October, 5th October. So 1.5 months now. Yeah. So 6 weeks. 6 weeks. Yeah. Yeah, I think within the next 1-2 weeks we should have some decent enough result, I would say. Yeah, and then maybe we need some polishing, some performance optimizations, and then hopefully it will be all functional and good. And then maybe we can move to the next thing. Yeah, well, one step at a time, right? One step. Okay. Yeah, let's review this next session. Then I wish you a great day or night. Until next time, goodbye.